Dear students, now we will find the rank of the matrix A by using row reduced form. See, the rank of the matrix can be found in two ways, either by reducing it to row reduced form or to normal form. First, let us find out the rank of this matrix by using row reduced form. Row reduced form means the first element of the matrix should be 1, and below that, if you have 3 rows, then below that zeros, and other elements can be like this, and in the second column here it should be 1 or it can be any element, then 0 and some element. Example will take like this. Now we observe this matrix here 1, 3, 6. This is the principal diagonal. So below the principal diagonal all elements must be 0, and above the principal diagonal there can be elements. This is known as the echelon form, or we call it as row reduced form. Row reduced form. Now we will take up an example and we will work out. That is, find the rank of the matrix A 1, 3, 2, 4, 2, 1, 5, 7, 2 by row reduced echelon form. Now let me consider the given matrix. So the given matrix is here is A. A is equal to 1, 3, 2, 4, 2, 1, 5, 7, 2. Okay. Now according to the row reduced form, the leading entry should be 1. Leading entry means the first element of the matrix. So here the first element of the matrix is already 1. So any operations are not required for the first row. Then we will pass on to the second row. So A is congruent to, we will take 1, 3, 2 first row as it is. Then second row we have 4. This we must make 0. To make this 0, let us take the operation that is R2 is equal to R2 minus 4R1 we will do. See, R2 minus 4R1 means here we have R2 is 4 first element minus 4 into 1 is equal to 0. So first element of the second row is 0. Then coming to the second. So 2 minus 4 into 3. So which is 2 minus 4 3s are 12, which is equal to minus 10. Then third element, that is 1 minus 4 into the third element in the first row is 2. So you will get 1 minus 4 2s are 8, which is equal to minus 7. Then third row we will take. Third row also we should make this as 0. So to make this as 0, let us have the operation that is R3 minus 5R1. See, first you have to operate with R1. Then 5 minus 5, the first element is 0. Next is 7. 7 minus 5 into R1. You see, 7 and R1, the next value is 3. 5 3s are. So 7 minus 15, it is minus 8. So minus 8. Then next element is 2. 2 minus 5 into 2, which is equal to 2 minus 10, which is minus 8. Now further we must make this as 0. To make this as 0, first let me take this as 1. So you will get A is equivalent to 1, 3, 2, and second row I am making this as 1. So it is R2 is equal to minus 1 by 10 R2 I will take. Minus 1 by 10 R2. So it becomes 0, 1, because minus 10 by minus 10 it is equal to 1. Then it is 7 by 10 minus 10 cancels here. Then next row as it is we will take in this. then further we will simplify. So our next operation should be this minus 8 we should cancel. So A is congruent to 1, 3, 2, second row also as it is. Only in the third row I should make changes. So that is R3 is equal to R3 plus 8R2. R3 plus 8R2. So you will get minus 8 plus 8 into 1. This becomes 0. First element becomes 0. So 0 and this is 0. Then minus 8 we have in the next row also. Minus 8 plus 8 into 7 by 10. 8 into 7 by 10. So which is equal to minus 8 plus 56 by 10. So which is equal to minus 8 plus 5.6. So you will get this as minus 5. In 8 if you subtract, it is 2.4. See, further you cannot simplify this because you cannot have further operations here. So this is the final echelon matrix. In the final echelon matrix, we have 3 non-zero rows. Final echelon matrix A has how many non-zero rows? 3 non-zero rows. 3 non-zero rows. Therefore, the rank of this matrix A is equal to 3. That is denoted as the rank of A is equal to 3. See, like this, if how many non-zero rows are there in the final matrix, depending on that, we find out the rank. If it has 3 non-zero rows, the rank of the matrix is 3. If it has 2 non-zero rows, the rank of the matrix is 2. Like this, we find the rank of the matrix by reducing to row-reduced form. In order to reduce this to row-reduced form, the first leading element should be 1 and below that zeros, and in the second row also, first element is 1 and below that there should be zeros. Below the principal diagonal elements must be 0 and above that there can be elements. So reducing like this is known as row-reduced form. Here in this matrix we have 3 non-zero rows, therefore rank is equal to 3. Thank you.